Go ahead and fill this due now in your notebooks. Give yourself a chance to work it out, so you can pause this video. Then when you're done, go ahead and unpause it, and we'll talk through it together. With your radians, the positive is that your denominator automatically tells you your reference angle. So since my denominator is a 3, I know that my reference angle is 60 degrees, okay, or pi over 3 as we talked about last time. Where we do need to still find out our coterminal is because we need to know what quadrant it's in. For that, first off, looking at this, you know it is less than 0, so I do have to put this number between 0 and 2 pi. So I'm going to add full revolutions to it. So I'm going to add 2 pi. We need a common denominator to be able to do that. So this is going to turn into a 6 pi over 3. When you do that addition, this is negative 5 pi over 3. Means I need to add again, so plus another 6 pi over 3 gives me a pi over 3 angle. What this tells me is that this is a quadrant 1 angle. Okay. Then going through our special right triangles, since it is cosine, it needs to be a over h. So adjacent to a 60-degree angle is the 1. Your hypotenuse is your 2. And in quadrant 1, cosine is positive, so my answer is 1/2. Looking at number 2, 3 pi over 2, since there is a 2 in the denominator, you should recognize that this is a quadrantal. Okay, 3 pi over 2 is your previous 270, so my ordered pair would be 0, -1. Then it is cotangent, which is a over o. A is x, and your o is always y. So filling in my numbers, x was 0, y is -1, so the cotangent of 3 pi over 2 is 0. Going down to the bottom two, we're going backwards now. Okay, so we need to isolate my theta first. So technically, remember, your theta is the arc secant, and I'm going to unrationalize this of -2 over √3. Okay, it helps to unrationalize it if you need to visualize it a little bit better. But what we can decide from this, secant, remember, is related to cosine. So this is h over a. So it's adjacent to √3, and the hypotenuse needs to be -2, which means my reference is 30 degrees, which we now know is pi over 6 radians. Secant is negative in quadrants 2 and 3. Okay, again, we got that by looking at our cast. Okay, so in quadrant 2, it is 5 pi over 6. Again, you can use any of those formulas or your chart to get through that. And then in quadrant 3, it is 7 pi over 6. So these would be your two answers right here. For number 4, cotangent is -1. Again, that is O over A, which with this one, this is a tricky one because this is a 45-degree reference angle since it is 1. Cotangent and tangent are the only time that you see 1 in a special right triangle, but it does happen quite a bit. 45 is a pi over 4 reference angle. Cotangent is negative in quadrants 2 and 4. Okay, since it's positive here in 1 and 3, it is negative in 2 and 4. In quadrant 2, it would be a 3 pi over 4 angle. And in quadrant 4, it would be 7 pi over 4. Okay, we're going to go ahead and get your homework grades next time. You can take a chance to talk through any homework problems that you have that were very similar to these. That should hopefully help you out. When you are ready, we're going to go ahead and start these notes. This is your title for today. We are still in 6-1. We're just going to take it a little bit different direction today. Today we're going to talk about comparing central angle to arc length to the area of a sector because all of these are closely related to each other. I'm going to draw you in a picture. Again, you can pause this video as you need to make sure you have plenty of time to do it. If I have a circle and some random central angle, so remember with that your vertex is at the center here. We don't necessarily know where it's at. I'm just going to draw a random one. This central angle is related to both the arc, which your arc length, and I am going to color code this, your arc length is the actual distance along the edge. So if you were measuring it in centimeters or inches, how long would that be? That's what we call your arc length. It is also related to the area of the sector that I'm going to color in red here, okay, which is the actual area of that like pizza pie that you're eating or whatever it may be. All three of those numbers are related, and I'm going to give you some relationships on the next page that put them together. And this next page is what we're going to talk about much of the time. But this just gives you a visual of what we're tying together. These four fractions are how all of the numbers are related. So you're going to write down all four. Again, if you need to pause it to be able to write it down, that's fine. These first two you saw last time. So these two are the blue, and they talk about your central angle. Okay, with these you have to decide whether you were given degrees or radians, so you use the appropriate one as is. On the green, this is dealing with your arc length, and what you will notice is this formula on the bottom. What you should recognize this as is your circumference formula. So this on the bottom is the total arc length around the entire circle. What this proportion is going to do is let me figure out the portion of the circle that I'm talking about. The red is your area of a sector. Oops, wrong color. And again, what you should recognize is that on the bottom, this pi r squared is your total area, and it's set with the area of your sector. What each of these is doing, it is taking the part of your circle over your entire circle. Anytime you do one of these problems, you are going to pick two of these that relate the information you're talking about together. So for example, just to get started, go ahead and write this one down, and then we're going to talk through it. For this one, what we are looking at is you have to figure out what you know, which here what we know is the central angle. We are also given the radius, which is going to be helpful, and we want to know the arc length of that portion of the arc. So what that means is I'm going to set up the formula that relates those together. So for example here, I was given my central angle in radians, so I need to do theta over 2 pi is equal to your arc length over your total circumference formula. And then we're just going to plug this in. So what I'm going to do is it's going to be 2 pi over 3 is my theta over 2 pi equals s over the 12 is the radius. So I'm going to do 2 pi times 12. When you start to condense this, so I'm going to need to multiply by my LCD here, which is 3. Those cancel, and you get 2 pi over 6 pi. On the right side, if you start to simplify that, I can make this really just 24 pi. Remember, you can simplify this also to 1/3 if that helps you. And then you're just thinking of this as cross multiplying. When you cross multiply this, your arc length is 8 pi, which is about 25.1 centimeters. Again, go ahead and write this one down. Pause it so you have a chance to work it out, and then we will go through it on here. With this one, the only real difference is that you are given your central angle in degrees. So instead of selecting my radians formula, I'm going to put the 200 over its total, which is 360. Here I still want the arc length, and I'm still given the radius, so I'm going to do my s over 2 pi times 20. And then you're going to go ahead and cross multiply and solve this. When you are done, you should get 69.8 centimeters. Okay, this is a similar problem, but now it's sector area. So go ahead and write it down and give it a try. See how it goes. And then unpause it when you're ready to talk about it. With this, your central angle is pi over 4, so that is in radians. So I'm going to do pi over 4 over 2 pi equals, again, I want area of a sector, so I'm selecting my area formula, the pi times radius squared, and your radius is 5.3 squared. When I simplify this fraction right here, I'm going to multiply by 4 on top and bottom to simplify that complex fraction. On top you get pi, and in your denominator you get 8 pi, which you can absolutely simplify to 1 over 8 if that helps you. Okay, this is equal still to your area over pi times 5.3 squared. When you cross multiply this, your area should be about 11.0 centimeters squared. Go ahead and write this one down, and we'll give it a try. Again, unpause it when you're ready to talk about it. The 1250 is a degree over your total of 360 is equal to the area over pi times 220 squared. Okay, and then you're just going to cross multiply this. So I'm going to do 1250 times pi times 220 squared divided by 360 should give you an area of 527,962.1 meters squared. Okay, with this, keep in mind your radius is massive, and so is your central angle. This is multiple revolutions, so I should expect my area to be massive. The main reason I have this one in here is to make sure you're taking that into account of that your size. If it works, it's totally fine. Okay, go ahead and write this one down and give it a try. Again, unpause it when you're ready to talk about it. Here I want to find the central angle in radians, so I want to know theta in radians, so over 2 pi. When I know that the arc length is 15 and the radius is 5, so again you're using your 2 pi times 15 formula. Oopsies, times 5, I apologize. 2 pi times 5. Okay, when you cross multiply this, you're going to get 30 pi over 10 pi, which gives you just 3 radians. It is okay here that my radians cancel it out. We are used to seeing it with pi, but this one shows you that sometimes it won't have it in there. It can be literally any number you want it to be. For number 6, go ahead and write this one down. Unpause it whenever you're ready. Here I want to know the radius of the circle. I know the area of the sector is 150 square feet, so I was given area, and I know the central angle is 3.56 radians. So, since I want to know the area, I need to use my pi r squared formula, so pi times radius squared, which is what I want to find, equal to my central angle in radians, so theta over 2 pi. Plugging in what I do know, this one's a little bit different. I know the 150 over pi radius squared, and I know the 3.56 over 2 pi. Okay, when you cross multiply this, you're going to end up with 3.56 pi r squared equals 150 times 2, so 300 pi. And then you're going to divide both sides by this 3.56, so r squared equals about 84.269, and so on. When you square root that, your radius is 15.1 feet. Number 7 here, go ahead and write it down again. I want to know the arc length. I know the area of the sector, and I know the central angle. So I really want an arc length, but I can't start with that yet because I know 2 other things. So I'm going to have to start with my area formula and my central angle formula in degrees. Okay, because that's my totals that I was given. I was given the 270.5 over pi r squared, and I was given the 150 over 360. Similarly to the last problem, you can solve for your radius, and you should get 14.4 feet. You need to pause it to make sure you can get that. That's perfectly fine. Once you know that, then you're going to backtrack to find your arc length. So I need to use my s over 2 pi r. I'm going to plug in the 14.4. And you can absolutely pick either one of these fractions. To me, I would always pick the simpler one. So I'm going to set this equal to 150 over 360. When you solve this problem, you should get 37.7 feet. This is our last example. And it's kind of similar, so take a second to write it down and give it a try first. Here we know the arc length and the area of the sector, so those are the formulas I'm going to set up first. I know it's 200 over 2 pi r equals 500 over pi r squared. But this one does get slightly more complicated. When you cross multiply this, you're going to get 200 pi r squared equals 1000 pi r. Your pi's do cancel. If you want to divide here, you can divide by 200 pi, and you're going to get r squared equals 5r. What you have to remember is you cannot just divide a variable out of your problem, so what we have to do is subtract this 5r and then factor this. You have two terms, both have a variable, so I'm going to pull out an r, and this tells me then that my radius is either 0 or 5. Since we're dealing with a radius of 0 doesn't really make sense. It wouldn't exist then, you wouldn't have a circle. So what we know is our radius is 5 inches. Once you know that, then, again, we're going to keep going and find the actual central angle in radians, so theta over 2 pi. Again, you can pick whichever one you want. I'll just use the 200. And I'll plug in this 5. When you do that, your theta is 40 radians. This video is going to be uploaded to Canvas, so if you need to check out there to get it to see any parts you may have missed, feel free.